So we know that this is 5. We know it's 5 because if you look here, the variable num words is equal to 5. So it actually just is the number 5 here. That actually is what has been replaced. Num fields here is actually 2. Now, how do I know that this value is actually 2 here? Because I know that there's actually 2 columns, one for the word, one for the description. And I know that this is 2 because this defines the value of these words here. So let me explain a little bit about what enums are, because part of this was like, hey, you know, there's something in here, there's some things in this program that aren't really clear, but enums are one of the things that are like, this is actually seems a little bit complex, but it just represents a number. So when you see an enum like this, what it's actually, just think of an enum as it's just a number. It's a number like 0, 1, 2, 3. Each of these values inside an enum, inside these curly braces, just represents a number. You can interchange between the word and a number anytime you want to. So if I were to say like int my value equals 6 plus hint, this totally works. Like hint is actually just the number 1. The way it works is that when you see an enum, the values within the enum are assigned a number in increasing order, starting with the first one. So this one is equal to 0, the second one is equal to 1, and the last one is going to be equal to 2. It automatically assigns those values to these words. That's all really an enum does. It just lets you give more information about what a value could be. So when it says num fields here, it's actually 2, because I know it started at 0, went to 1, and then went to 2. Okay? All right, so moving on. So we seed our randomizer. We get a choice of random words. We pick the row we want with our random number. And then we get the word itself, put it into here, and we get the hint, and we put it into this variable here. So these two variables store the word and the hint respectively. The rest of this code here is responsible for actually jumbling up the letters. So it's actually responsible for swapping letters around in the word. So let me show you actually, if no one actually stepped through this, let me show you actually how this works, because it's kind of neat. The way it just takes the word and swaps letters inside the word around until it actually gets something. So here's the wall. And I'm actually going to do this. I'm actually going to pin this guy here. So there's this variable here, jumble, which stores the word wall. We get the length of the word, which is 4, and then we go through this loop 4 times based on how long the word is. We pick a couple of letters, and it looks like here we're going to swap the A and the L around. So the way we do that is we store off the letter at index 1, A. We take the letter at index 1, A. We assign equal to the letter at index 3. So you're going to see it says WLLL temporarily. And then we take that letter we stored, which was the letter A, and we put it at the end. Okay? So it swapped those two. It's going to do this 4 times. So in this case now it's going to swap 1 and 1, so it's actually not going to do any swapping here. These two indexes it's going to swap is going to be 1 and 0, so it's going to swap the W and the L now. So it's going to put the L where the W is. It's going to be, the W where the L is, and be WWLA, and to put the L back where the W was. So that's all this loop is doing. It's going through and it's swapping letters around inside the word. It does this 4 times. Sometimes it doesn't actually swap anything, but you'll see the word WLLA as the thing that actually gets printed to the screen. So like we're actually going to let this run. So there's WLLA. And based on what you guess, it stores off what they typed in as the guess. And if it equals the word hint, then you're going to print out the hint. Otherwise, you're going to say, sorry, that's not it, and you're going to repeat the guessing. So it asks them again for another guess here. And until, if the guess is equal to the word, it breaks out of this while loop. Or if you type in quit. And then once you actually get to the end, it'll tell you that you guessed it. So that's the structure of the program. So really the key is where do you put your scoring? And so you can actually put it right here. And so the score should be initially based on the length of the word. However, I wanted you to remove points from the score if you actually took the hint. So in addition to storing off the length, I can actually store off the score and make it equal to the length right here. this score is just an integer value. I just want it to represent a number. In this case, I want to represent exactly how long the word is. So I can just take that score, and I don't need to change it. Except here, I'm going to type out the score like so. So now when I guess the word, I'm just going to print out literally the length of that word right here at the end. What is this one again? Glasses. So my score was 7 because there are 7 characters in that word. But now I want to set it up so if I type in hint, I will decrease the amount of score I get. So this is persistent, which I think is 11 or 10. Yeah, 10 characters. So I want that actually to be like 2 less, or maybe even just cut it in half. Every time I guess the word, I'll cut it in half. So here, if I type the word hint, I know that I've gotten the hint. So I can just multiply it by 0.5. So I can take the score, I can reduce it by half. So if I type glasses, which would be 7 points, if I type a hint and then type glasses, my score is now 3. Okay? All right. Any questions on this? So a lot of this was like, hey, there's a kind of a pre-existing program that you guys have to kind of work your way around, which is a very common thing, right? Like, it's pretty rare that you're starting from scratch when you're working on a game, like a game project. You're most oftentimes, like, you spend your time working within someone else's code. So I think this is a good example of that. All right. Cool. Did everyone hand in their homework? Let's see. All right. Let's go over the lecture for today. And I have some practice for you guys to do as well. I forgot to install the fonts. So we're not actually in week 9, we're in week 10, but this is week 9's lecture. If there's nothing else you remember from this class, I think functions is probably one of the things that's worth remembering, because what we've been doing up to this point has not been using functions, which is actually pretty unrealistic. So that's why I want to spend pretty much the whole time talking about what functions are and giving you guys opportunities to write some, because functions are so critical to like learning programming. Every programming language has some variant on how a function is implemented, because functions basically give you the ability to write something once and use it multiple times. That's the key reason why functions are so important. If you don't use functions, you have to basically repeatedly do the same code over and over again. You have to write the same code. And functions let you do that one time and then just reuse it. It's like a tool that you can use. And because functions are so ubiquitous across all programming languages, C++ has a lot of different ways that you can interact with it, but I'm going to go over the kind of the very basics of how functions work. But I just want you to keep in your head that a function really is just a way to reuse a piece of code over and over again. Okay? There are other ways to reuse code in C++, specifically using macros. However, I'm not going to really go into that. I want to focus on functions because functions are way more common. Like, games are typically made up of hundreds, if not thousands, of functions. Overwatch probably has like on the order of 10,000 functions, if not more than that. Each function doing something different. And so a function really is, at its core, is just a piece of code with a name. You give a name to a chunk of code that you've written, whether it's 1 line or 100 lines. You give that piece of code kind of a name so that you can say later invoke that function and execute that code whenever you want to, right? And a function works in that you can reuse that code by calling the name of that function. And functions also have ways you can pass it information and ways that that function can get information back to you. It's like a way to not only reuse the code, but pass information back and forth to that function. A lot of times you need a function to do stuff for you, okay? That's why functions are really important, because they basically let you do whatever you would normally do inside of your main function, where we've been doing all of our code inside of our one main function, and break it apart into smaller pieces. Okay? So there are primarily two kinds of functions that you kind of have to deal with. You have functions that return a value to you, and you have functions that don't return a value to you. And those are kind of the primary difference. I want you to remember that there's two kinds, okay? We've actually already used a few of these functions that have both, both types. So for instance, let's say you want to calculate the square root of a number and assign it to a number. There's a function that exists that will return you the result of the square root operation on a value. The squirt, SQRT, is a built-in library function that you can call wherever, and will take a number that you tell it, take the square root of that number, and give you back the result. Okay? That expression, x equals the square root of 6.25, you are invoking or calling. You can call either. We use both. We use the term invoke or call. We typically, yeah, it's kind of both. We kind of use both interchangeably to square root. You're invoking that function to square root. The expression, the square root of 6.25, the whole thing, the parentheses and the number inside of it, is a function call. Meaning that that line right there is making a function call. It's calling out to that function. The function itself that you're calling, it's kind of weird, it's the called function. It's the actual called function that you invoked. And then you have another one, which is, who's the one responsible for calling me? And that is the calling function. Okay? This is just more like imagining on the phone. Who are you calling? I'm calling square root. Who's the one calling square root? That's me. And square root is the guy that got called. Okay? Let's see this in action here.
Calling you out square root.
Yeah, I'm calling you out square root. I'm saying that you got some numbers to calculate for me. Okay. So there's the square root of 6.25. You can see the result there. So this is me calling a function here. Notice what I do with a calling function. Remember, this function call will give me back a number. It will give me back the result of the square root of 6.25. Now, I can do whatever I want to with that result. This right here, the stuff that I've highlighted, is an expression, just like any other expression. It's just like me adding two numbers or multiplying two numbers. This gives me back a value. I can use that value in a cout statement, or I can assign that value to a variable, like so. And then I can print out that variable here. You have your choice of how you use the result of this function, okay? Does it make sense so far, like what that's doing? Like calling out and it's giving back a value. This is one of the two types of functions. Okay. There's another type of function that doesn't return anything. Okay. If you have one of those functions that doesn't return anything, that means that when you call it, it won't give you back a value. Which means, in that case, if you have a function like that, which I'm about to show you, you can't do stuff like this. You can't assign it to a variable, and you can't put it into a cout statement. Let's talk a little bit more. So in this case, how it works internally for the one that returns a value is very similar for the ones that don't return a value. Is on the left here is the calling function. This is the guy that's calling. This is the int main function. So look at the numbers here. It starts at number 1. The first thing it does is say, hey, I want x to be equal to the square root of 6 plus 25. It's like, cool. All right, well, I don't know what that is yet. I'm going to call that function for you. It goes off. The actual execution of the program jumps to a place in code that's probably not where you wrote it. This right here on the right side is essentially the C++ code implementation for how a square root is calculated. Okay? It goes off to here. Then it will do a bunch of work to calculate the square root. It does this kind of behind the scenes. So that's number 3 here. It runs a bunch of code. It actually has probably several lines to actually calculate square root. Calculating square root is kind of an expensive operation, so it probably takes a while. When it's done, it hits the end of this arrow here. And then number 4 says, oh, I found out what the square root is. I'm going to send that back to whoever called me. So I'm going to go back to the calling function. And now my square root function that I called originally has returned a value. So what I effectively do is I actually replace what that square root function is with the value of what it calculated. Okay? This happens synchronously, meaning that it happens in this order. So while it's calculating this function, nothing is happening over here. Okay? It effectively jumped from here, went down, came back and told us what that square root is. Okay? So in the case of here, when I'm calculating the square root of something, x is now, no, I don't want it. So x is currently nothing. So that little yellow arrow, when I advance, is going to go into square root, do a bunch of work, and then come back and replace square root and put that value back into x. Here's a breakdown of how you call functions. We've actually already done this a couple times, but because when we did the SFML stuff, this is kind of how we did it. But I do want to break down exactly what is involved in calling a function. With respect to this type of function, it actually returns a value. Okay? So we have this function called square root. That is the name of the function. When you guys write your own functions, you're going to have to give every function has to have a name associated with it. Okay? So you know how to call it. You have a set of opening and closing parentheses, which always is there when you're calling a function. You can never not have those parentheses. Okay? If you are calling a function, the way you know you're calling it is because you have parentheses there. Within the parentheses, you have argument information. You're not always going to have information that you pass in between the parentheses. However, when you do, you may also have more than one. Whatever it is, it has to live within the parentheses. In the fact of square root, you're telling it what number you want to take the square root of. A semicolon as the end of the statement, and then you're assigning it equal to the value of x. Questions on this stuff? This is the breakdown. This is how you're going to call most functions. Some functions, you're not actually going to have this left part here, where you have the x equals. So I want to go over another type of function that doesn't have a return type. So remember I said you can assign this thing to a value, right? Well, if I have a string, I'm going to have this string, and I'm going to call clear. That is a function I'm calling that's name is clear. What's in between the parentheses? There's no information I'm passing into that function, right? This function is what's called a void function. It doesn't return anything. It goes off, does a bunch of work, and then doesn't return back a value. Which means I can't do something like that. I can't assign testString.clear, which is a function, into result, like I can with this function call here. Okay? So those are the two main types of functions. I'm going to give you guys some practice on writing both today. In order for you to actually you can use functions all you want to, but I want you guys to actually get used to like writing functions. So in order to write functions properly, we're going to be making what are called function prototypes. Function prototypes is just a name for saying, hey, I want to write a function now. I want to be the one to write a function, and here is what I want my function to look like. Okay? You tell it whether it has a return type, which is one of those two functions I talked about, whether it's something that returns a value or returns void, which means it doesn't return anything, the name of the function, and what kind of arguments that that function has. Okay? We're going to get into prototypes more. Briefly, for if you do have multiple arguments, like look here, for answer equals power of 5.0 to 8, you just separate them by commas. Okay? And keep in mind that not every function call has arguments that you pass to it. Okay. So, oops. This is an example of a function here that has both a prototype and an implementation. And I'm going to break this down a little bit. So it's just a regular old main function here, int main, just like what we always have. But there's two new parts to it. Look at where these parts live. One of these guys, this void assignment int, lives between the pound include statement and the int main statement. He lives above that. That's where the function prototype lives. This right here is where you're basically defining the parameters to what your function looks like and what it returns, and what arguments it takes. This right here is what you need if you ever want to actually write a function. You want to have prototypes. When we get into working with multiple files, that becomes very important because that's the only way you can actually tell things ahead of time what functions are available to use. And at the bottom is our actual function implementation. Okay? It's a void assignment int. That's where we actually put the lines of code that define what our function does down here. So when you are writing a function, there's two key parts that you always have to think about. This right here is the syntax for how you actually write the function implementation. Okay? Everything in italics here is stuff that you have to write. The first thing is the type. Okay? That first value is the return type of your function. Return type means, does this function give you back a value when someone calls it? Does it give you back a number? Or sometimes will it give you back a string or a bool? Or, in the case of this, you can also have a new return type, which is void. Void is a special thing that's used for functions, is only used for function. It says that, hey, this function I'm about to write doesn't return anything. You can call it, but I won't actually give you back anything as a result. Okay? Type here is any variable type. You can use any variable type that's been declared. So you can use strings, you can use any SFML type in here. But it can also be void. Okay? So when you put void in that type, calling that function means it doesn't produce a number that you can assign a variable to. It means you can't use that function to assign a variable into. Look here, this assignment operation calling assignment3, that won't compile because it won't tell you. So the way you call those functions is you just put them on a line by themselves, and you put a semicolon, and that's it. You put them on a line by themselves, you put a semicolon on them. Okay? That's how you do it. You can't use them in cout statements or anything. If it has void on it, it means that it has no return value. Okay? The next thing for functions you have to keep in mind, you just have to give it a name. Think of something clever but not too clever. Think of something that is short but descriptive. Try not to use more than like 3. Keep it within like under 5 words. 5 words is kind of like the limit. If you can make your function 2 words or even less, that would be best. Make it something that is actually reasonable, though. Make it a word. Don't make it a letter. Within the parentheses is going to be our argument list. An argument list is what values do you want someone to have to pass into this function when they call it. A lot of functions need information at the time that you call it to do its work. In this case, the assignment function, it takes an integer with the letter n. So what is an argument actually made up of? An argument list is a comma-separated list of variable type and name. That's it. You can sometimes have 1. You can have none. That could be empty if you want it to be. Okay. So in this case here, in our assignment example, if I go back, look at our assignment functions here. Inside parentheses. I'm going to talk about the prototype in a minute. When you're actually writing the function, there's 2 parts to it. There's the prototype, and then there's the implementation. I'm going to just talk about the implementation right now. When you add in the argument list, every argument you specify needs to have a type and a name. The way that arguments work in functions are actually pretty neat. Okay? When you define an argument in a function, you're forcing whoever calls that function to give you back something that meets those requirements. When you say, hey, if you want to call this assignment function, you have to tell me a number. You have to give me a number for me to do what I need to do. That means that no one can call your function without passing in a number. They're required, in order to compile the program, to pass you a number. So look up here in main, on the second line in main, where we're calling Simon with the number 3 in it. So that number 3 that gets put into this function call here, when we're calling Simon, that number here, when we do our execution and we run off and do our this, when we go run our code, we also, along with number 2, where we're going off this extra place where we're running our code, we're also taking with us all the arguments that have been passed in. Okay? That comes with the function call. That gets passed along to the function call. Where does it go once it gets passed along? That number 3 gets paired up with the argument list. So now, when that function is run, when I go back to this example, and you're calling number 2, when number 2 is getting called, and we're actually starting the number 3 where we're running our code. So here, I'm inside this line of code. I'm about to run this. However, that number 3 came along with us, and it got plugged right into that variable n. Okay? That variable n in my argument list is actually a variable that I can use inside my function now. So that variable n here, this is an argument. I'm running this code here. That number 3 actually got plugged in and assigned into n. So now I can use n inside my function when I'm writing it, and this number here is based on the number that was passed in. So this right here, what is this value going to be here? 3. This is going to be 3. This n, look what I'm using inside the function. Anything that's in my argument list is actually a variable I can use inside my function. It's basically been a variable that I declared So I can use n anywhere inside this function, but only inside this function. And this value is controlled by who calls it. Okay? Let's go over this example. Let me show you how this works. Okay, so I'm going to write this function Simon down here. Now watch what happens. I'm not writing the prototype yet. Watch what happens if I write this function Simon and I try to call it. Oops. I'm just calling Simon. It's right here. It's literally right here, right? But I can't compile my program. My error that I get is, hey, the Simon identifier is not found. It doesn't know where to find it. And the reason is because when it's compiling, it's going top to bottom. Okay? So look, it's running this compilation. And it's saying, hey, oh, here's my main. Cool, I'm going to call this function Simon. I've never seen it in my life before. I don't know who this guy is. I don't know where Simon is. You didn't tell me anything about him. I haven't gotten to this point yet. It doesn't go down here to figure it out. It's basing the information it knows up to that point. Okay? That's how the compilation works. So that's why a prototype is really important. Because now what I do is I want to write my function down here. Okay? In order to do that, I have to tell it, hey, trust me, I'm going to write a function for you. It's going to be called Simon. It's going to be great. Everyone knows it's going to be great. This Simon here, I need to tell you about it up front, though I understand. Okay? When you write a function prototype, there are the same parts you write when you're writing a regular function. The only difference is you don't have to write anything inside the curly braces. You don't even have to write the curly braces itself. So I'm going to write a function called Simon. I'm going to start with this. And that's all I'm going to do. I'm matching exactly what I wrote here. The only difference is I'm not doing anything about writing lines of code. I'm just putting that function, the type, the return type, the name, and then what arguments I want at the very top. Okay? This here is our function prototype. What this means is this is a very special syntax. It says, hey, this is a function I'm going to implement somewhere else, but for now, this is what it's going to look like. So whoever's calling it can trust that it's going to look like that when I actually implement it. This is very important for when you're dealing with object-oriented programming and multiple files, because oftentimes you're writing these as your header file function implementations. So the only thing, like let's say I want to write a new, let's say I want to create a new Overwatch hero, right? So there's a file somewhere that helps you do some of that work. That file just looks like a bunch of these function prototypes. It just is one line per prototype, one line per function. It doesn't have a lot of the function implementation in it. It's what's called the API, the Application Programming Interface. It's kind of the method by which you talk to it. So this prototype right here is exactly the same as this one here. Only difference is I have a semicolon. Okay? So if you want to write a function, you want one of these. Any questions on this so far? Like why this needs to be written up here? Just so that by the time I get down to this assignment code, it knows what to do. All right. I'm going to go into ways to change this in a second. I'm just going to run through this and show you guys what actually happens here. So watch what happens. Here's my yellow arrow, which indicates where my program is about to go. So that yellow arrow, turn on all my line numbers. That yellow arrow is right here, number 1. So it's going to go to number 2. So where is it going to go here in this file? Does anyone tell me where that yellow arrow is going to jump to?
22.
Down to 22, right? Or 23, close enough. That's what happened. That jump from line 15 to 23 is the jump here, number 2. Okay? That's where it went. Remember, it took along with it all the arguments that got passed. So look, I'm passing in the number 3 here. I have the argument the number 3 put into my variable here, n. The value of n now is 3 because that came along with the function, right? So now I'm going to run what's inside this function. Which is I'm going to print out need to jump. So you're going to see that on the console here. Need to jump 3 times. And then I'm going to go back. So I finished 3, so I'm going to go back to 4, which means where is that yellow arrow going to go next?
16.
16?
Or 15.
It goes back to the line that I called it, right? Close enough. So that's the path it takes when it calls a function. That's what it always does. Goes off, does some work, comes back. Sometimes when it comes back, it brings along the result of what happened in that function with it, based on the return type here. Okay. So that's great and all. But like, this function doesn't do much. Like, I could have just written this function inside main, right? I could have just done this. I could have just taken this whole thing and literally just printed out 3, right? Same exact behavior, right? So what is the benefit here? Why does this matter? Why is this so important? Well, yeah. Well, I wrote this function, and here's why it starts to get really exponentially more valuable. One of the reasons why it's so important to use functions is that now I've written this once, and now I can call it multiple times, okay? I can call this function like that, 4 times in a row. And look how small those lines of code are. It's pretty short. However, the work that it actually does is a lot. Like it prints out all that stuff 4 times. There's another part to this too. Writing a function like this means I can use it in different ways too. For instance, maybe I want to loop 10 times and call this function and pass in I. And then call this function and pass in 8, 12, 25. I'm not restricted to calling it the same way. Remember though, for a void function, I need to call it on a single line and that's it. There's more reasons why it's important. When you're writing functions, you're writing the implementation. You don't necessarily know. Actually, most of the time, you have no idea who's calling that function. Think about square root, for instance. Think about the C++ implementation for square root. Think about how many people in suits and glasses are writing that function. How many people do you think call square root across every programmer that does C++ in the entire world? How many people do that? Probably a lot, right? Probably a ton of people use that one function. Well, there's one guy in a suit who writes that square root function that can change that square root and effectively change how it works for every single one of the people that calls it. Millions of people that call it, he can change it. For instance, maybe he makes it a little bit faster, right? Maybe he makes it use a little less memory. Maybe he makes it a little bit more accurate. I don't know. He does those things. He can make those changes, and he doesn't know who's calling it. Maybe it's some NSA guy. Maybe it's a game developer here in California. Maybe it's an indie developer in Europe somewhere, right? It doesn't matter. He changes that function. He doesn't have to know who calls it. Because he wrote it, because it lives inside of a function, the people that call that function have no idea really how it works, and they don't care. But if it runs a little faster, that's great. But they get the benefit of that without having to worry about it. It's kind of like how firmware updates work. Like you get like a firmware update for your phone or like an OS update or something. Like stuff happened in the background. The way you use your phone typically is about the same, but sometimes it's a little bit faster. And here's the benefit to that. Like for instance, I can use this number in different ways. You guys see what I just did here?
function within a function.
I call a function inside my function. So I'm taking that number that they pass in and I'm printing out another string. So everyone who calls that function now gets 2 lines of code. Haha. So even though I'm calling this function this many times, I didn't change who calls it or how they call it. I changed what the function does. Right? This is the power of why functions are so important. This is how you collaborate on projects together. Imagine this entire classroom is all in the same game team. We're all making the same game. The way we divvy up the work is often within separate files, but also we focus on our work usually within functions. So like I would be responsible for writing like, I don't know, collision detection for my function. I would do that, but you guys can all call it and trust that it'll work properly. You don't have to even worry about it. I'll take care of it for you. You could also do nefarious things like actually not have an implementation in here. Yeah, well, then the function doesn't do anything. Or do whatever you want to, like you could just literally just call rand here. You don't even have to use the variable if you don't want to. That variable n, even though they're passing it in, you have control over what that function does. Right?
You didn't need a lot of them.
Yeah. So those are the parts of a function. Okay. So that was a void function. Remember, that void functions you have to put on a single line. You can't use them as return values. Let's go into another example that has a return type. So here's another example. There's our assignment function, which takes an integer. Before I go into this, I also want to talk about ways you can change this function type. So remember, I talked about this function prototype. You are optionally required. You have an option to name your argument here. You're required to name your argument here in the implementation. In the prototype, you do not have to give it a name, which means you can actually just delete the name if you want to. I recommend not doing this. I recommend naming it all the time. I would literally just do the exact same name down here. But just when you see it in the book, you'll sometimes see stuff like this. That just means that they decided not to give a name in the prototype. However, you have to give a name when you implement it anyway. So we tend to favor the side of like, hey, just give it a name here. Secondly, after all that, there is a way to not have to write a function prototype. I kind of don't want you guys to do this, but I want to show you that you can do this. A function prototype is just basically a promise to say, hey, I'll write this function later. However, you can put this function right here. Right? You can actually implement it right there. And if you do this, you don't actually need the prototype. You can actually just delete that and have your function prototype and your implementation all in the same place, as long as you put it at the top of the file. Okay? I recommend not doing this because more often than not, when you start working with games and multiple files and projects, you're going to be writing prototypes anyway. This might be fine in a few rare cases where you put the implementation here. But I just want you guys to get practice writing prototypes, so I really don't want you guys to do that for now.
So don't write the code on top.
Yeah, just for now. Like, just when you get comfortable and you're used to writing function prototypes and you're like, okay, I understand how they work, then if you want, it would only be for speed's sake. It would only be because you're in such a hurry that you don't even have time to write a prototype. Organization-wise, it's always better to put all your prototypes up top. If you start putting all these functions above main, it starts getting hard to like find where main is, and you bloat the top of the file, which makes it difficult to see and read. But also, you can't easily move that stuff into separate files. Like if you actually do all that stuff, and let's say, well, my one CPP file that I have, we're going to get into multiple files in next class, but my one CPP file I have is like 30,000 lines of code, because I have all my functions here. I need to break this apart into smaller files. If you want to move that, you're going to have to write prototypes anyway. So by writing prototypes ahead of time, you get to save some effort later. Okay, so here's a second example of a prototype. So that function, the return type here is double. It means that that function, which is named taxes, returns a double. And it takes a single argument, which is a type of double. Notice they don't give it a name here, although they give it a name now. They give a variable named t. When you have a function that has a return type that is not void, now you can use that function in an expression, or you can use that function in like a variable assignment, however you want to. However, there's some rules that come with it. If you want a function to return something, you have to follow this syntax. So here's another example of a function that returns something. This is the special piece right here, this return. I'm going to go over that in just a minute. That prototype up there now returns an integer. It takes a single integer, and it looks like this down here. This function converts stones, which is a unit of measurement. A stone, it's a unit of measurement. It is. It's like a real unit of measurement. Into pounds. And does some work, and then comes back. The way that you get this information back, remember, if I go all the way back to my previous slide here, remember this where it returns back to the calling function? Remember, I said that sometimes you can have it take back with it a result. If you have a function that returns something other than void, you have to tell it what you're returning. You have to tell it the actual result of the value of the thing that you're returning. That is where the return keyword comes in. That is telling C++, hey, I'm done inside this function, and you can tell that guy who called me, here's the information that he was asking for. Okay? Return says, hey, return out of this function, I'm done, and right after you put what you're going to return. Oftentimes it's going to be a variable name, which means you're going to return the value of what that variable has. So if I pass into this function, let's say I pass into this function 10. What's going to get assigned into pounds here? 140. 140. Let me write this function and show you guys how this works. What's another interesting conversion we can do?
Feed the integers. Feed into meters.
What are some other conversions we typically do? Let's just do still in the pounds. If anyone has any other examples.
US dollars to Japanese yen.
Remember, you can leave this one out if you want to, or you can implement it. This is my prototype I've written. Notice it has a green squiggly on it. The reason why it has a green squiggly is because, like, whoa, you told me about this function you're about to write. You promised me you're going to write it. I don't see it anywhere. So it starts to freak out a little bit because it's like, I don't know where this function definition is. I'm getting a little worried. Don't worry, we'll write it. I'm going to take the stone to pounds, and here's how I typically do it. I copy the whole line. Coworker of mine was telling me how this is like an unavoidable consequence of working in C++ and being a programmer. This action I'm about to do, I've probably done like 100,000 times by this point, is converting a prototype into a function is really just amounting to copying it. I copy this whole line, scroll down, I paste it, I delete the semicolon, and then I put curly braces in there. Because that's all it takes to convert a prototype into a function. That sequence of operations I've done so much that, and actually Visual Studio now helps you and will do that operation for you a lot of times if you wanted to. However, that operation is something so common that you just get used to doing it. You just copy the whole prototype, you paste it down here, and you delete the semicolon, and you put some color braces in there. All right. So here's our stone to pounds function. Remember, you have to tell it to return something. If you have a function that returns something other than void, meaning that it's a integer or a string or a bool or a character, you have to have a return statement somewhere in your function. Otherwise, it will be a compile error. Okay? So even if I return 50 here, That's fine. As long as if I don't return a function, it'll say something like not all code paths return a value. And notice the error I get when I forget the return here. Stone to pounds must return a value. You have to tell the person that called it, here's the information you requested. Even if it is a single number. The real result is it's going to be s times 14, right? That is the result of this. It's going to be whatever you pass in times 14. So now I have my function, and because it has a return type now, I can use it inside of an expression. These kinds of functions that have return types are the most versatile. You can use them pretty much wherever you would use a variable or a number, in this case. Anywhere you would use a variable or number. So like I can have, like that. I can use this function and assign it equal to a variable. Remember, I can't do that up here. This won't compile. You're not allowed to do this statement. You're not allowed to use a function that has a void type in an expression like this, an assignment operation. But I can do that for this guy here. In addition, I can just do cout. I can use this function inside of a cout. That's no problem. Remember, you can use this anywhere you would use a variable, effectively, or even just a single value. Which means you can also use this in like a for loop like this. Anywhere. A function effectively replaces or can take the place of any place you'd use a variable or a number. Okay? You can call a function anywhere, like this, as long as it has a return type. If it has a return type of void, you can't do this. I can't do this for Simon. Like if I try to put Simon 25 here, it doesn't know. Because remember, Simon doesn't return anything. It literally doesn't have any information that it passes back with it. Okay? So there's the two primary differences here. Okay, so let's just step through this, and I'll show you guys what this looks like. It looks very similar to the other function call. My yellow arrow here, which is on line 19, will jump down to line number 40 here. So I'm going to go into here. My variable s here, which I passed in 5, now stores the value 5. I'm going to do some work, which is to return 5 times 14. Goes back to here. Notice that pounds is still this number. Once I step, pounds becomes 70. Okay? Same thing here. Here's my cout statement. That yellow arrow, where is it actually going to go first? Where is this yellow arrow going to go? Into this function, comes back, I step into it again. Holy shit, what is this? Right? This code that I'm in right now, this is actually the function for piping in values into the cout stream. This is actually what you guys have been calling the whole time. Every time you do cout, you call all this. This behavior gets executed to put it into the cout statement every time. You've been calling functions effectively every time you do this. That right there is a magic operator that does some work. It's very similar to a function, but I just want you to keep in mind that in C++, when you're calling code, it jumps around all over the place. Okay? Stone to pounds here, I'm going to step in. That yellow arrow is going to go back down to number 40 again, and it's going to come back to stone to pounds. And now, what did it put here?
140.
140. That's the result. However, it does this every time through the loop. So watch what happens. I'm going to do this again. It calls it again. Every time through the loop, it calls it again. So I'm effectively calling this function 140 times. What if I put I in here?
Infinite loop? Or does it not run?
This will work. However, if you use a variable inside of a function call, just keep in mind what that variable is at the time you call it. In this case, it will return 0, so that loop will actually never run. But keep in mind, you can pass in variables into these parameters too. All right. When you call functions, sometimes you can have multiple arguments you get to pass in. When you're passing them in, just separate them by commas. When you're declaring the arguments for the prototypes here, separate them by commas. You have to declare each argument pair with a type and a name, which means here, I have a type. My first argument is a character with a name C. My second argument is an integer with a name N. So here's what I want to do.